Okay, class, as usual, another 1 minute for your friends. Okay. So today's lesson will be the wrapping up the kinematic. Just we're going to do the passes for 1 hour. Then tomorrow we're going to start with a new topic, dynamics. Okay. So this is the past year compilation. I think it's already in the time, right? So we did some of the questions already. Let me select some questions for you. We discuss together. So now it's going to be overall kinematic topic from the beginning, from the graph to the projectile. Okay. Okay. So, okay, this question, November 2. What's your answer? So, which statement is true for the projectile when it's at Q?
C.
C. Okay, from the chat, I got A, B. You write your answers.
Wait. Huh.
I got a A, I got a B, majority going for A. So, majority going for A. 5 to 6 of you A.
Oh, A. It's it's A.
A, A. The horizontal component of the projectile acceleration is 0. Yes, correct. A is definitely correct, right? A is definitely correct. A is talking about the AX. AX is always 0. No doubt about that. Whether got air is no air resistance, AX is 0. So without air resistance, A is correct. B, the horizontal component of the projectile velocity is 0. The horizontal component of the projectile. This is talking about the UX, your UX, and also your VX. It's not 0. It should have a value. VX always have a value. It's not 0. If not, if VX 0 means it won't experience projectile movement. Okay. So C, the kinetic energy of the projectile is 0. Yeah, C, you have to put it into consideration. When you go to the top, the kinetic energy is 0 or has a minimum value? It has a minimum value. It has a minimum value. So C, the kinetic energy of the projectile is 0. No, it has a certain minimum value. Okay. The momentum of the projectile is 0. No, if it has kinetic energy, it should have momentum. So it also can't be 0. So answer is A. Okay. Okay. Let me talk about kinetic here. Okay. I thought of asking this question end of the class because this is quite tricky. Okay, let me ask now. Okay, the question I want to intend to ask is this one. Okay, go to the whiteboard. Okay, you don't need whiteboard. Just the whiteboard. Okay, this is a difficult question. It's a passe came out. An object was launched as a kinetic energy when it launched is E. This is the kinetic energy the particle possesses, E. The Ke is E. Okay. And it was launched 30 degrees from horizontal. Okay. When the object reached the top, it's at the top, how much kinetic energy it possesses? How much is the kinetic energy it possesses? Give in terms of E. How many E? How many E? At the beginning, the kinetic energy is E. After, when you go to the top, how much of kinetic energy it possesses? How many E? Is it half E? Is it quarter E? Is it 0.2 E? How many E? I want the number. How many E? Okay, 1 minute for you to think. You can put your answer in chat. This is one past year they asked. What is the kinetic energy at the top? Okay, I think I received one answer. See, it's half E. They put half E. Someone put E cos 30. Half E, half. Can it be half? Some said half E. Okay, let me get more answers. E sine 30 over 2. What is E? Oh, E, kinetic energy. Sine 30 over 2. Sine 30 over 2. Sine 30 over 2. Put a number. Sine 30 over 2. No, can't be sine. Ah, yes. Half. Oh, yes, good. One of you wrote a very good point. Yes, half E cos 30 squared. Okay, that makes sense.
Half.
Can you give me a number? How many E? The cos 30 squared, can you simplify it, give a number?
Oh,
How many? I want a number. No need to give me in cos or sine, but give a number. The cos, you resolve it, put a number, tell me the number. What's the number?
80.
Maybe three significant figure. Okay, some of you put 0.375 E. 375 E. Okay, so let's see which is the answer. 0.375 E. Okay, so here assume the velocity is V. V, the velocity is, sorry, U. So the horizontal component of the velocity will be what? The ux value will be what? Will be u cos 30. Will be u cos 30. We don't know the u also, we just introduce the u. When the object is at the top, the actual velocity v, we know is v squared equals to vy squared plus vx squared. The two components squared, you get the v. But at the top, which value becomes 0? We know the vy become 0. No vertical velocity. So only Vx is alive. Vx is alive. Vx squared is alive. Therefore, at the top, the V, the actual velocity of the V at the top is actually same as Vx, which is same as your Ux. So the velocity at the top is actually U cos 30. The speed is traveling. Okay. So what is the kinetic energy at the top? So the Ke at the top, of course, one of you wrote this, but so half m. The V is actually what? The V is U cos 30 squared. It's V cos 30 squared. So finally you get half what? M U squared cos squared 30. Cos squared 30. So this is your kinetic energy. But finally, you know, half mu squared is what? Fu squared is actually your E. Your E is your half mu squared. This is your half mu squared, right? Okay, initial velocity is U. So it's actually E cos 30 squared. That's the answer. So can you put cos 30 squared? How much you get? Cos 30 squared. What do you get? 0.375. This is 0.375. Anyone?
So it's what half mu squared?
Yeah, half mu squared become E.
Oh,
Half mu squared is E1. The initial velocity is U. So half mu squared is E1. Okay, so cos 30 squared, 0.75. Okay. So cos 30 squared, so 0.75. So the final answer should be 0.75 E. Okay. So the kinetic energy at the top here is 0.75 E. 3/4 of the kinetic energy from the beginning is retained at the top. We launch at 30 degrees. Okay. You're working. Remember at the top, it still has kinetic energy. The speed is moving at the top is exactly Vx. It's same as Ux. Any question?
Okay.
Can I? So if I launch this with 45 degrees, if I launch this with 45 degrees, then how many E will be on the top? So it's going to be cos 45 square of E. Eh? It's your 30, but 30 replaces 45. You get the new kinetic energy. Okay. Okay. So this is what I want to clarify here. Okay. On top still have kinetic energy. Okay, I go back. Get to the question. More questions? Okay, let's go down. Okay, the question I want to ask you is there is one bike. This one. Come on, class. 1 minute for you. Give me the answer. Do the working. What was the speed at takeoff? They're asking what speed it take off. They're asking for the U is what? Okay, the question is U. This is also something new. We never come across question asking for U. Normally U is given. This time they're asking for U. But we will have a clue. You check which side got 3 information. I think you can proceed from there. Gather your information. Vertical, horizontal. In your real life examinations, paper 1 is 40 questions. 40 questions given for 1 hour, 15 minutes. It's about 75 minutes. So one question you must spend around less than 2 minutes. That's maybe to be safe side, 1.5 minutes. So this question you should be able to finish in 1.5 minutes. Actual target timing. But now it's okay. You just start A levels. Try to get the idea first. It take a little longer, it's fine. Okay, I received one answer. Okay, you say D, and says D, looks D. Anyone got D? Anyone got a different answer? Okay, 2 of you got D. All of you going for D. Good news. Yeah, everyone getting the same answer. As you see, is it D is correct? Another one. Yeah, 3 of you going for D. All answers I receive is D. Is D's answer. You know SY, SY given. SY is negative 1.25. Something new, you got SX this time. XX is positive 10. We're looking for you. So what is that? So your UY, we know is exactly 0 because horizontal launch. UX, we know is actually exactly U. U, horizontal launch. AX, we know is 0. Okay. AY, we know is negative 9.81. And SY is negative 1.25. And SX is found to be 10. Oh God, a lot of information. You're looking for U. You're looking for U. So this is U. Okay, I think Horizontally, you need three informations, but as usual, vertical you have three. So find the time, use the time on the horizontal, and you can find the answer. So check S equals ut plus half AD squared, find the time, put it here over here, then you find the Sx, okay, find the Sx, Sx equals to uxt, okay. So all of you got D, 20 meter per second, should get 20 meter per second, okay. So this is the question, how do you, as I said many times, how do you gather your information is important, positive, negative, and so on. Okay, any question from this question? Hope everyone got D. We're looking for you, Okay, so if don't have questions, I go for more questions. Clear this. Okay, this one. 7. What's the answer? November 4. This is so D. Sorry. So D. The vertical component of the acceleration of the stone is the same in everywhere. They are talking about AY. AY is always negative 9.81. We're taking upwards as positive. So of course D is the answer. D is the answer. AY. They are talking about AY, right? Vertical component of acceleration. Okay, I think it shouldn't be a problem here. Okay. Okay, hold on. Okay, this is a very important question. Question 7. Okay, this one. What's the answer? This is what? Yeah, this is Juno 5. Juno 5, question 7.
B.
Did A? Can gravity change?
No.
Gravity never change. Wherever gravity not affected by your state of movement, right? Whether you are moving up, moving down, or you stationary, gravity never change. Gravity is always 9.81. So when you are at the maximum height, your gravity is still 9.81, right?
Yes.
So what's the answer? Everyone going for, oh, sorry. I got a answer B and C, B, majority going for B. Yes, good. The answer is B. Okay, the answer should be B. Okay, the gravity never changed. Okay, you know, earlier we sketched a graph for AT graph. When you take upwards as positive means gravity already fixed. Gravity is always AY is negative 9.81. Okay, whether the object going up or whether object is stationary for a while or whether object going down, A never changed. A is 9.81. Gravity unaffected by your state of movement. Whether you're moving or not moving, AY is always negative 9.1. If you take upwards as positive. Okay. So graph AT graph also you get like this, negative 9.81. If you remember, we draw earlier. Okay. Okay. What is the answer going to be if I take downwards as positive, not upwards? I take downwards as positive. Then what's the answer going
C.
to be? Then it's going to
C.
be
C.
going to be C. So either answer going to be B or C. No way A or D. Remember. Okay. And I was in Form 5 also. I was like quite confused in this part. I always took gravity on top is 0. It's not really. Gravity is always constant. Either B or C is the answer. Okay, good. Please correct the statement. So in this case, is the B is the answer. Okay, this one. What is this? This is November 5, question 11. Along which direction or directions do forces X on the stone at X? The force they are talking about is the net force law. Not the net force. So what's the answer? So your friend gives me C.
See?
Can you go for C? Anyone? Any other answer? So I got C as the answer. I got more answers now. Okay, so type brown. So what's the answer? Anyone?
See? Oh,
C, yeah?
thank you. See, I see.
Only force pulling it down is what? Only force when object
Gravity?
weight. Only force acting is the weight. Okay. An object in a free fall in a projectile movement, the only force acting down is the weight, the mg. Only mg is acting down without air resistance. Without air resistance. So the answer should be A, xv. Okay. The only force acting on the object in projectile movement is gravitational force, force due to gravity. No other force. You don't have any other force. No air resistance. You don't have xh is actually the component of the weight. That's it. It's a component. You can break them into components. But the actual force acting is only the weight. Yeah, so answer should be A. Okay. So any problem here? So cannot go for C, XV and XH. You are going for components. No components. Actual force is the weight. Okay. So should be A. Okay, this is another good question. Okay, this one. One example. Okay, this is one structure. Which year is this? That's November 5 again. Okay, read the question. A stone on a string is made to travel along a horizontal circular path. The stone has a constant speed. Define acceleration, 1 mark. Acceleration is rate of changes of velocity. We know that. Get the easy mark. Okay, next. Use your definition to explain whether the stone is accelerating. 2 mark. If the stone is accelerating, can you get the 2 mark? You need to explain 2 marks. Anyone?
Can we see the diagram?
Okay, let me show you the diagram. It moves in a circular path with a constant speed. Is it accelerating? Constant speed. Anything move with a constant speed in a circular path. Is it accelerating?
I mean, it is getting inwards.
So I got receive answer no, never accelerates. Or one of you said never accelerates. It never accelerates. I receive more answers. Let me see. Or two of you said never accelerates. Anyone? Is it never accelerates? You must have a reason behind. Yes, one of you. The third person said yes, it accelerates. The reason he gives reasons to, very good. The reason give is because the direction changes. Yes, good. What about direction changes? If direction changes, what change? Direction changes. At the beginning, it moves like this. This is your initial velocity, let's say. Then it moves here, this way. Okay, it moves here. This is your final velocity. Okay. Do you have changes in velocity or not? What is the changes in velocity? final velocity minus the initial velocity, right? The first topic you learned.
Yes.
What is the final velocity? Final velocity is moving like this. Sorry. Huh? Check. So, okay, final velocity is moving like this. Okay. Then at the tip, you join negative of the initial, right? Initial moving like this. Initial, I think, moving like this. Okay, like this. Negative of the initial. Then what is the changes? Changes is here. What? There is changes. Here, changes in velocity. Okay, this is your changes in velocity. The changes in velocity is found to be towards the center. So there is changes in velocity. Anything move with a constant speed, if direction change, because direction is changing, there is a change in velocity. How do you change velocity? In your for your earlier studies, how you can change velocity? You change magnitude, you change velocity, right? 30 meter per second, suddenly you go for 40 meter per second, or velocity change. Okay, that's one way. Can you change velocity without changing the magnitude? Like you're traveling 30 meter per second, and if you change direction and you are still traveling 30 meter per second, you are changing velocity. You experience changing velocity. Velocity can be changed either changing magnitude or changing direction. If you change direction, there is a changes in velocity. Remember, when object change direction, there is a changes in velocity. You will have changes in velocity. So therefore, it accelerates. That's the answer. Okay. So what's the answer you should give? Because direction is changing, therefore velocity is changing. Because acceleration is rate of changes of velocity, therefore it accelerates. Okay, any question? So there is changes in velocity. Okay. So do you learn last time that do you need to apply force when you want to change direction of an object? Do you need to apply force when you want to change direction of an object?
Yes.
Something moving like this. Let's say this is Earth. Asteroid is moving straight. Okay, asteroid coming towards the Earth. It's changing direction. The asteroid is changing direction. Why changing direction? Because Earth apply force, right? So to change direction, do you need to apply force? Yes, you need force. If you apply force, what is force means? Force is rate of changes of momentum, right? Your early studies.
Oh, yes.
When you apply force, the body must experience changes in momentum, right? Okay. Oh, must be MA, right? Must be MA1. So the body must experience acceleration. It accelerates because there is a changes in velocity happens. Okay. So conclusion, the answer, yes, it accelerates. Something new. Okay. So let's we move on. Okay. Before that, any questions? Okay, I received some questions. Let me check. Okay. So how much is some of you asked? How much is the acceleration? Okay. How much is the acceleration? To calculate the acceleration, we need to know the time. You want to know the acceleration. Acceleration is what? A equals to v minus u over t1. You can find v minus u from the graph changes of v, but time needed. If time given, then you can find the acceleration. If time not given, you can't find the acceleration. But it accelerates. Okay, it definitely accelerates. Okay. So let's see, move on. Yeah. Okay, more questions, eh? Okay. Juno 6, question 7. What's the answer? Anyone? Which measurement are needed to measure gravity?
A.
You want to measure gravity. Let's say you are in your room, you want to measure gravity. Okay, what measurement you take?
A.
A, height of the ball and the time of the fall. Yes, correct. I think we did one experiment, right? So, yeah, all of you say A. We use what formula? S equals to half AT squared to find your A. So to find the A, you need displacement, height, and you need the time. So answer should be A. Okay. So what instrument do you use? We use two photo gate, up and down. We measure the height. The height must be as long as possible to reduce percentage uncertainty in the A. What type of graph do we plot? We plot, we get S and T value. So we plot S versus what? S versus T squared. Best law. So you got a straight line. So the gradient represents what? Gradient going to be y equals to mx, your linear law concept. The gradient will be what? The gradient will be half A. One structured question came out like this. So gradient is half A, not A. It's half A, your linear law. Okay, so height and time needed. Okay. Any questions? Okay, so I think everyone give me the A. Okay, this question. Question 8. This is November 6, question 8. Read through the question first. So X and Y moving. This is a velocity versus time graph. Scroll down. Okay, scroll down. Which statement is correct for the graph? Okay, put it on top. Okay. Which statement is correct? Okay. I minimize it. Okay, which statement is correct? X and Y are the same at 2.5. They are intercepting at 2.5. Okay. Which statement is correct? Anyone? The acceleration of X and Y are the same at 2.5.
No. Wait. Acceleration initial.
Acceleration at 2.5. Okay, I receive answer. So the answers, some of you put answer stating is a D. This is D. Okay. I see most or two of them say, two of you say D. D. Distance traveled by X and Y in 5 seconds period are the same.
D.
Within 5 seconds they travel the same distance. How do we know? Do the area under the graph, if they meet at 5 seconds, means the distance travel must be the same, right? That means area under graph of X is the distance travel, right? The area under graph of X is it same as area under graph of Y at 5 seconds? The area is the same. If it's same, then D is correct. Check, please check the area. Oh yeah, two of you said C. Okay, I think you should go check the area. Check the area. Check the area for X. X is, what is the area of X? Half times height times width. Height is how much? Height is 5 times 5. So what is the distance traveled by X? It's 12.5 meter. Okay. What is distance traveled by Y? Trapezium. Trapezium formula is what? Half 2 plus what? 2 plus 3.
Same.
Same. Same. Same. It's 12.5. Good. So both travel the same distance. So the answer is D. Very good. So it should be D. So area under graph is the same if they meet up at 5 seconds. So they are definitely meet up at 5 seconds. What is happening at the crossing point? What is happening? Anyone? What is happening at the crossing point? Do they
Both
meet up?
me. Wait.
They never meet, right? Actually, at the crossing point, what happened? The velocity is the same lah. That's all. Okay, the velocity is same at that moment, but they are not meeting each other yet. Who's ahead? Who's ahead at this moment? X ahead or Y is ahead at this moment? Y is ahead. Very good, because area under graph of Y is greater than the area under graph of X. So Y is ahead. Okay, good. So this is how you analyze the graph. Okay, area under graph is the displacement. So answer is D. Okay, so let's proceed. More questions? Okay, this is a very good question. 7. Juno 7. Come on. Question 7. An object has an initial velocity u. So vector diagram was given. What is the length of x? If you write the equation for x, the vector equation, x equals to what in terms of u and v? I think you can able to get the answer. Okay, so anyone? I hope I received some answer from in the chat. Write the equation for x. X equals to what in form of u and v? Then think about the 4 kinematic formulas. That's my hint. That's my clue. You can get the answer.
Mhm.
Okay, write the x equation. X equals to what in form of u and v? Think about the 4 kinematic formulas. You can get the answer. Okay, I receive answers. Okay, let me check. Okay, so C. So your friend said C. Win said C. The others, do you think C is the answer? Okay, let me see. I got more answers now. Okay, so one of you said it's B. B or C? I got more answers now. Okay, another one said C. So C, yes. Is it C? That's good. Majority say C. Of course, the answer is C. Yes, the answer is C. Should be C. Why C? X equals to diagram. Negative U,
Negative plus v.
negative U plus B. Yes, it's negative U plus B. Oh, X is actually what? B minus U. What? So the kinematic formula, B equals to,
Or 80. Yeah,
uh,
it's 80.
so V minus U is actually 80. Acceleration time. So C stands. Good. Okay, so this question is vector diagram. X is U, negative U plus V, so V minus U, so it's 80. Okay. Okay, more questions? Okay, number 8. Okay, give me the answer. Number 8. A stone is dropped. Do the working. Sorry. Yep. When it's dropped from a top of a tower of 40 meter, the stone falls from rest and air resistance is neglected. What time is the what is the time taken for the stone to drop the last 10 meter? Okay, put your answer in the chat. Hope everyone got the same answer. Okay, so 40 meter. They're asking what is the time taken for the last 10 meter. Last 10 meter, what is the time taken? Okay. The initial velocity here is 0. So do you have 3 informations? You need to get 3 informations. Okay, last 10 meter. Anyone got the answer? Okay, I receive answer. Answer was A. Okay, your friend placing A. So is it A?
Yeah.
Yes. Okay, many of you A. Yes.
0.39. So yeah.
0.38 something. So 0.38. How do you calculate? You calculate the time taken to travel for 30 meter. Then you
And
find the
then
time taken to travel for 40 meter. Then you minus lah. Minus both, you find the time for the last 10 meter. Because we want to make use of the U0. Okay, you want to make use of so 30 meter, find the time taken to travel 30 meter. So U0, S is 30, A is 9.81. Okay, up to you. You want to take downwards as positive, then A is positive 9.81 lah. Okay, if you take upwards as positive, then A is negative 9.81. Displacement also will be negative 30. Choice is yours. Okay, but you'll get the same answer. Okay, so yeah, good. So A. Okay, more questions, Okay, Juno 8. Question 6. What's the answer? Okay, someone says C. Okay, more answers. Let's see more answers. Everyone saying C. This C is answer. Speed is constant, direction changes. Yes, good. Speed is constant. Yeah. And something move with a constant speed, if the acceleration is here, or in other word, acceleration perpendicular means actually the force is perpendicular. When you apply force perpendicular to the direction of motion, the object will change direction. But the velocity still will be v. The force still will be the same force, but the speed does not change. Speed does not change. but the direction will change lah. Why speed does not change? Anyone? Why speed does not change?
Hmm.
This is actually I never teach you, but you learn in your O level already. You already learn O
Because
level.
it's 90 it's because force that is 90 degrees won't affect
Why?
that. Is it because it's 90 degrees?
Yeah, because 90 degrees work done will
Or work doesn't affect if 90 degrees.
work is force times displacement or distance traveled to the direction of the force one. If force is 90 degrees to the direction of displacement, work done is zero. There is no work done. Normally, work is the one going to increase the energy of an object, increase or decrease the energy of the object. Because here no work done by the force, so the body does not gain kinetic energy. The velocity won't rise. Okay, sorry, the speed won't rise. So yes, good. The D is answer. Why the speed is constant? The answer you should give is work done by the force is zero. Why the work done by the force is zero? Because force and displacement is perpendicular. Okay, this is the work concept we'll be learning next topic. Another two topics ahead, but you learned this before. Okay, so the answer should be D. Okay, this reasoning you can add on. For time being, I don't expect you to know this, but this is the explanation. After two topics later, you should be able to explain this one. Okay. Any questions from here? So D is the answer. Okay. Okay, this one. 7. Which year is this? This is November 8. Okay, get me the answer. Okay, so I received the answer. Answer said is C. C? C is the answer. The stone has a constant upward acceleration followed by a constant downward acceleration. Okay, so someone said A. A or C? Think carefully. Gravity, is it change direction? Or many said A. Many said A. Good. So the answer should be A, right? The stone has a constant horizontal velocity. It has a constant vertical acceleration. The acceleration is always downwards. Wherever it goes, the acceleration is downwards because the acceleration AY is the negative 9.81. So it's always constant. Okay, negative 9.81. It's always downwards. Okay, accelerate downwards because Earth pulling it down. Earth not sometimes pulling it down or sometimes pulling it up. So you can't say accelerate upwards, accelerate downwards. Okay, acceleration always downwards. Okay, so try to correct your rephrase your sentence. Acceleration, vertical acceleration always constant, always downwards. Answer is A. Okay. Okay, some more questions. Okay, this is going to be the last question. Okay, this one. Question 8. What year is this? June 09. June 09, question 8. Okay. Okay, so I got the answer. Good. Class is quite good, active. So answer given is so two of you said C. Yes, correct. Agree, yeah? So all of you said good. So C is answer. Constant velocity, constant acceleration downwards. Okay. Okay, class. So that's all about this topic. This is kinematic. You have more questions, you can give a try. If you have a problem, you can ask me the next class. Next class, I'm moving on to the next topic. Okay. So we've done plenty here. Okay. So try all the questions in these passes. Okay. Another one question I like to highlight here is this is extra information. You see, when a projectile is launched and launch, okay, let's say you launch with 30 meter per second. Okay, let's say you have a strength, let's say, to throw a ball at 30 meter per second. You want to get maximum range. You want to get a maximum range, like Olympic, throwing the ball 30 meter per second. The person has is fixed strength, only can able to throw, let's say, 30 meter per second. What angle he should project? What angle he should project so that the range is maximum? The range is maximum. You get the maximum range because he can't increase the velocity because it has his fixed strength. What angle he project, he can get a maximum range. Anyone?
Hmm.
What do you think? I got answer. Good. So I expected the answer. Yes, 45 degrees. 45 degrees. Okay. So this is the fact for you to remember. You want to find maximum range, the angle should be 45 degrees. Okay. You can prove this. Can you prove to me why theta is 45 gives you the maximum range? This is going to be like a 5 marks question line exam. Not even once they are so far, but other part like IB, Australian programs, they used to ask this. Prove the range is maximum and the angle of launching is 45 degrees. Prove it. Okay, I'm leaving to you as your homework. Okay, you can give a try. If you got good, okay, you can put it on the WhatsApp. Okay, so prove what? Why when prove that theta 45 degrees gives you the maximum range. Okay, it's half page of derivation. I'll leave it to you as homework. Okay, the vertical and horizontal component is the same. Not really. Not about vertical. You need to derive it and show. Okay. Okay, I'll leave it to you. You think first, then I help you later about this. Okay, class, any questions about today's class? Okay. If you don't have, so tomorrow we're going to start with a new topic, fourth topic, dynamic, about forces, Newton's law. Okay. You can get the notes from the Times. Okay. Take the topic 4 notes, then we discuss tomorrow. Any questions? Okay. So if you, any questions? No, Okay. If you don't have questions, okay. See you tomorrow. Bye.